Good afternoon. On this video I'd like to show you how to use Neurospectrum.net software for recording and analyzing EEG in intensive care units. First of all, let's look how our system looks like. Here is Neurospectrum 65 EEG machine based on mobile trolley with all-in-one PC with touchscreen, with video camera and photic stimulator. This system is located in our office before installation in clinic. From backside it looks like this: EEG machine, photic stimulator and video camera. You can connect both touch-proof EEG electrodes, or you can use electrode systems with predefined EEG electrodes also. Here is how our system looks at intensive care unit. You can see that flash stimulation is now going on and system is located near the patient's bed. Here assistant put electrodes on the patients, fill caps with gel. Now impedance is okay and they are ready to start, and here is monitoring going for this patient. So now let's look how to use Neurospectrum.net software for recording and analyzing EEG in intensive care units. Here is our software, where you can see main menu, toolbar buttons as in all usual Windows software. On start page you can see also frequently used operations here, and few templates for different kinds of EEG examinations, including routine EEG, video EEG monitoring, evoked potential, cerebral function monitoring, polysomnography, neurofeedback and so on. On the central part you can see list of recent patients and recent examinations which were done on this software. For example, if we click one, software will open this examination for reviewing and analyzing. Here is our examination. It's EEG plus video. You can move video window, for example, like this. You can use transparency for it, for reviewing simultaneously EEG and video, or you can dock it to the right or to the left side of your window, like this. You can scroll EEG traces with mouse wheel or using navigation functions, page by page, with page down keys, page up keys, home and keys and other operations. Before we start new examination, I'd like to show you the Montage Editor window. In this editor you can select current montage which you want to use for your new examinations. For example, monopolar 21 channels with one ECG channel. And also here you can create your own montages. To do it, you just use create new montage button. For example, put the name of the montage and then you can choose what electrodes you will use in your montage. Also on the right side you can set up some parameters of your montage. For example, you can choose a referential electrode. You can set, for example, ear electrodes, average ear electrode, consolidated ear electrodes, central electrode CZ, or, as in my case, separate ref EEG electrode. To add monopolar or reference channel, you just press left mouse button to the channel name. If you want to add bipolar channel, you just press left mouse button, move button and release it on another channel, like this. It's very easy. You can add both monopolar and bipolar channels in the same montage. Also, we have few polygraphic channels which you also can use, for example, for recording EMG, EOG, ECG channels. And also we have a few additional channels like SpO2, DC channels, direct current channels, respiration, airflow channel, and others. I will not save this montage, and I'll choose monopolar 21 montage as default. Now let's start our new examination using template video EEG monitoring, this one. First of all, I need to put all information about my patient. For example, like this. I can put also age, sex, diagnosis and so on, but now I just put only the name. Here we can see our software, where in the central part we will see native EEG traces. Now it is empty. Also we can see here our durations according to current montage. We can see new toolbar buttons for impedance measuring, monitoring, recording, flash stimulation, and so on, event markers. And for sure we can see our video window, where now we can see our virtual patient. It's just a toy to make a demo. On the bottom part you can see a list of functional tests which you can use during EEG recording at intensive care unit. Also above the traces you can see acquisition parameters, such for example sensitivity of traces, its mean scale, sweep speed, low frequency and high frequency filters, notch filter, current montage. For example, we can select montage before, during or after acquisition. So to start recording we just need to press this button, but before we start recording we need to put electrodes on our patient and use impedance window to be sure that we put electrodes very well. Now you can see that all electrodes are marked with red because my electrode cap is not connected to the patient, and I will use the tank with water. I just put all my cap in the water now, and you can see that impedance now becoming better. Now it is all in green color, and in the table you can see the real values of impedance in kilo ohm. As for ECG channel, I have no ECG electrodes now for this demo. That is why it will be red, because you can see here it's break, no connection, electrical connection on this channel. So when we put all EEG electrodes on our patient, we can start acquisition, but usually before acquisition we use monitoring, just for review the quality of the signal, how it looks like. If it is everything okay, we will press record button to start our acquisition, and you can see that background test was started automatically. We also can start flash stimulation, after flash stimulation, auditory stimulation, pain stimulation if it is necessary, and other functional tests if we will use it during our recording. And now you can see that video is recording. This is the timer, and here is the current astronomical time on our web camera, and we can see native EEG traces. There is no patient connected to our amplifier, only water. That is why the traces are quite flat, but I can emulate some activity if I will move my electrodes and wires, and I also can even emulate some epileptiform activity like this, just making special movements. And you can see that the software automatically detect this epileptiform activity, give us the red text, give us the sound, a warning sound, and also software mark this episode with green color here in navigation line under the traces. Here you can see that software already mark our epileptiform activity, and after reviewing we will be able to find this episode very fast and review if it is really epileptiform activity or maybe it is just an artifact. Let's do it one more time. I'll emulate epileptiform activity. Here is spikes and sharp waves which software find automatically, and you see that now it is warning message, epileptic seizure detected. Software mark it with green color automatically. And if, for example, I stop my recording, or if I, for example, not stop but open extra EEG window using view main menu, extra EEG window, I will be able simultaneously review online recording EEG traces and offline already recorded signal. Here you can see also the same navigation line where we have two green marked episodes, and I can move to each of them only with one mouse click and review if it is really epileptiform activity or it's just, for example, an artifact. I also can mark here some episodes with right mouse button. I can define it as, for example, artifact, as epileptiform activity and other episodes, and I also can move some episodes to the left to correct the position of them, or if I'm not agree that this is epileptiform activity, I can just remove it with a right mouse button like this. Now it's removed. Okay, if we stop acquisition, software will automatically save it, and we can see also this selected green episodes which are already marked as epileptiform activity. We can correct, start and end, and we can continue going to another one and review it also and make decision if it is really epileptiform activity or if it is an artifact. In acquisition panel you can see that we had already recorded 3.5 minutes, but to review these native EEG traces it also take quite a long time. So to decrease time for reviewing native EEG traces, we usually use such analysis tool as trends. I'm just opening trends window. Here we can see the timeline. Here is 1 hour, 2 hour, 3 hour, and this is the time which we will be able to review only with one screen, not reviewing EEG traces like this with mouth wheel or with page down keys, but we can see all EEG activity in one screen. Top trend is a density spectral array, which shows us spectral power of such bands as delta, theta, alpha and beta rhythms. And here we can see amplitude integrated EEG or AEG trend, which shows us minimum and maximum amplitude range for each time. As for AEG trend, we have the special help window on the right, where you can see how it is calculated. Here is on this picture very easy to understand that low frequencies are shown on the bottom part of this AEG trend and high frequencies are shown on the top part. That is why we can see the both minimum and maximum amplitude by each time, and we can decide if it is normal or not using the special AEG patterns. There are a lot of AEG atlases published. You can find one of them for free in the internet, And here you also can see several typical EEG patterns. For example, continuous voltage pattern, which shows now our normal EEG activity. Low amplitudes are higher than 5 microvolts, and high amplitudes are lower than 16 microvolts. It is a normal EEG activity with good outcome. The second pattern is discontinuous high voltage pattern, where we can see that minimum frequencies are quite low and maximum frequencies are quite high. This pattern is not so good as C and V, but it's also quite normal for intensive care unit patients. Next patterns are not so good. For example, burst suppression pattern, which shows us a lot of low frequency amplitude EEG, we call it suppression, and sometimes we can see like bursts with high amplitude EEG activity. Another one called burst patterns with a lot of bursts, and the most worst EEG pattern with usually bad outcome is nearly isoletic pattern, which shows us very low EEG activity, totally under 5 microvolts. All EEG activity is located here, and it's not good for the patient, for the outcome. Also, we have several samples of seizures or epileptiform activities, how it looks like on EEG trends, and you can see that it's also easy to recognize this epi activity using this trend. So I'll continue recording of our examination, and during this operation I'll want to show you a few real patients, a few examples how it looks like. For example, here is one patient. It is not intensive care unit, it is epilepsy monitoring unit. I just wanted to show you the difference between this EEG signal and other which were recorded in intensive care units. Here we can see quite good EEG traces with high amplitude alpha rhythm, maybe a little bit slow, but it's still high amplitude, normal EEG activity. And we also can see these two trends, density spectral array and AEEG. For example, on first trend we can see with the red color where the most big spectral power is located. For example, here where we are located now, it is a lot of slow wave and some activity in beta and alpha range. And if we move, for example, here we will see very high frequency and high amplitude EEG activity, and we can see with the video that it is some artifacts here. If we move, for example, somewhere here, we also can see some alpha activity as it's marked with red color here on the alpha and the beta bands. And the same we can see on the AEEG with amplitude. For example, here low amplitude is something about 10 microvolts, and high amplitude is something about 25 microvolts, and we can see it with a raw EEG. Now let's move to our example of patient in intensive care unit. You can see totally different in raw EEG here, and you can see that the amplitude is much lower here, a lot of slow waves, and we can see the same in the density spectral array. You can see red color only in low frequencies, in delta diapason, delta range. And the same we can see that on AEG trend we have quite low amplitude EEG activity under 10 microvolt. It's not very good for the patient and for outcome, but sometimes here, for example, we can see that AEG pattern is green, it's a continuous normal voltage pattern. But if we move here with the left mouse button, we can see that this is just some artifacts because of manipulations with this patient. If we move to another one, we also can understand with video that this is just high amplitude artifacts because of manipulations with our patient. But totally background EEG activity is quite slow, with only slow wave activity and a low amplitude of EEG. Another example of the same intensive care unit EEG, we also can see a very similar situation with low frequency. You can see only delta activity and low amplitude, but we have some hope with these green episodes, but unfortunately if we move here, we also can understand that it is some manipulations with our patient and it's artifacts and not basic EEG or electrical activity of the brain of this patient. Here we can see 10 hours of recording and we can move our trends through our examination. And on previous example we had 24 hours recording, and we also can move to the start or to the end of our examination with mouse and navigation keys. So let's return to our new examination within emulation mode. We already record 8 minutes. Recording is going. Using this acquisition panel, we can change the scale of the traces. We can change the sweep speed, for example, make it slower or faster, like this. We can change low frequency and high frequency filters. For example, if we want to clean our signal from extra noise or from, for example, EMG artifact or something like this, you can see you can choose the filter from the list, or you can put the number here if it's not present in the list, like this. If I want to put any frequency for our filter, I can do this easily. Notch filter, you can switch it off and we will see a lot of notch activity. I can switch it on and now EEG signal is quite clear. And as I told previously, we can select another montage even during recording. For example, we can choose double banana montage here for reviewing our EEG. After 10 minutes we'll go in recording. Software will automatically detect the EEG pattern. It is very low amplitude here, and the software already made this, and we can see the circle diagram where in future we will see the percentage of each EEG pattern. Now it is only one epoch which were analyzed, and we can see that it is undefined pattern. Software didn't define this pattern as some of EEG patterns according to this scheme, because we have no real patient. For real patient, for sure, you can see here software will show you the circle diagram, and you can clearly understand that a lot of activity, it's continuous low voltage EEG pattern. Sometimes it is green, but if we review it, we will understand that it is only manipulations with our patient, and it is artifact activity and not base electrical activity for this patient. So I think it is all I wanted to show you in this video. Goodbye.